Welcome to the top of the Cincinnati in the rarefied atmosphere of the shed. And don't let them get into the mechanisms of your machinery. They wreak havoc. Look what's happened to this one. Anyway, this will form the subject of an upcoming movie. Won't that be fun? But for today, I'm going to show you how I made this tool for countersinking. We'll get into that in a minute. Before we get into that, I need to tell you about another channel that I've been following. Model Engineering Adventures. Go and take a look at this channel as soon as you can. After you've watched this one, go and watch them. They're currently making a triple cylinder Stewart engine, and it's a very intricate and marvelous piece of engineering, and it's really a fascinating build. One of the most recent episodes was machining the crankshaft, and there's a lot going on that. That is a really complicated piece of machining with a lot of different journals in different positions, and two eccentrics machined into it, all out of one piece of bar stock, and it was really an excellent job that they did. But not only that, as well as sending me a sticker, they sent me this lovely card, and this is Michelle and Andy, by the way, and Michelle is an artist and she designed this card. I'm sure she's designed some others, so I'm going to go look them up and check them out. Anyway, that was delightful to get that this week. The stickers and the card had been in the mail for an extended amount of time and traveling around the world, I expect, but they got here safely, and now I'm going to add them to the sticker board if I can get down from here. Join me over there. Next stage on the wheel spacers is to put the chamfer inside the counterbore holes, and it's a 60-degree chamfer to suit the lug bolt that has to go in there. And I have, as it happens, this 60-degree chamfer set, which is an insert based set, and it's quite nice. Only trouble is this one is too small and actually won't touch the sides of the hole, and these other two are too big. They just won't go down inside the counterbore. So I thought about it. I thought, well, I could machine this down. I could just put this in the lathe and turn down the diameter until this one will fit, but then that will destroy it. I'd rather not do that. And when I look at it, it doesn't look that complicated, honestly. So I've decided I'm going to have a try at making one, and I'm just going to replicate this geometry as best as I can. So that's what we're going to do now. Stay tuned. Here's a model of the part I'm going to try and make. Now, I like to have a sketch or a drawing of things that I'm going to make because it just helps me think through the process and keep track of where I am. In the case of more complex parts, this doesn't necessarily meet that criteria, but in the case of more complex parts, building them up in the computer model is helpful to me because I can play around with how the cuts are made before I actually go and do the real thing and kind of see what the implications might be. Because I frequently screw up the order of processing parts and run out of material to hold on to and things like that. So sometimes it's a good idea. This didn't particularly need to be modeled, but this is a service that I provide aside from, you know, my day job is reverse engineering and drafting services for people. So I have SolidWorks, a full license, and so I just make use of it for my own stuff as well. So as you can see, easy enough part. This is going to be a 1-inch diameter carbon steel because I happen to have a chunk of it, and I will just machine the features I need on the end. Tapped hole to take an insert. Again, I've copied these as near as I can from the kit that I had, and have made a drawing which has gone mad. It's not really a drawing. I refuse to actually call this a drawing, and the reason is because it doesn't meet any actual drawing standards because it's got dimensions all over the place. What's happened is as I've gone through this and thought out the process, I've added reference dimensions with silly numbers of decimals here and there just to think through it, and this happens a lot on my drawings when I start them off, and when I start actually machining parts from them I start adding extra dimensions and things. So this is not normally what I would create to send to a shop. This is just what I end up adding stuff while I think through where I'm going to touch off and where I'm going to hold on to the part. But as you can see, it's not that complicated. There's nothing to do down here. This is all going to be stock. So it's a case of turn the taper, and then I'll set this part up in the dividing head angled at 30 degrees in order to machine these flats on the mill. Yeah, so come in from above, machine this away, and then turn it around 90 degrees using the dividing head and bring it down so that I can tap that hole for the insert. I think the most critical aspect of this is positioning this hole so that the insert is supported against this face here. And if I zoom in, you see I've sketched out my insert to make sure that I've got it where I need to be, and these dotted lines just represent the starting material. So that's what I said earlier on about being able to visualize the process in the drawing form, because I can look at the starting bar with just the taper on it and then kind of see how it's going to change as I machine the other features. So that's why I do it this way. Other people with more skills than I have can just do it in their head, and I think that's very impressive, but I lose track of where I'm at very quickly. So I make sketches or diagrams or drawings as I need to. Anyway, enough waffle, to the machine. Very straightforward setup here. The dividing head was trammed in, and then the head tilted up and aligned by tracking along the taper using a test indicator just to make sure that the angle was set correctly. Now I'll lightly touch off on the side of the part using the mark on the Sharpie there to establish location of the end mill. Sorry about the glare from these lights. I won't use these again. I didn't realise just how badly they kill the picture on the camera. So yeah, won't use this lighting again. Depth of the countersink is important because it's used to locate the spacer. Well, not locate it, but we're using these lug bolts to secure it. So I have to control the depth of the countersink reasonably well. So to do that, I'm going to use the steel ball trick. So I've got the quill extended all the way. I'm going to bring the knee up and take an initial cut, just a shallow one, and then put the ball in place, measure the height from here to the top of the ball, and then I'll know how far up to raise the knee to get to finished depth. And then, as I did with drilling and machining these holes, it's a matter of going around the bolt pattern and just bringing the quill down to full extent, and job done. Let's bring you in and have a look. So just this. We are looking for 9913. Which the astute among you will know that that means we have to bring the table up 3, 6, 1, 3. And that way our depth will be set. So set the knee dial back to 0. And away we go. 1, 2, 3. So that's the point 3. 6, 1. And I ain't going to worry about the 3/10. Now don't forget to take your ball out. Hope I did that maths right. That would look embarrassing otherwise. 9 minus 3 is 6. 9 minus 6 is 3. There we are. There. So we are 7.5 plus 15. Well, that's 990, isn't it? Yeah. I'll take being within a thou. All right then. You go out of the way, Mr. Depth Micrometer. So now what I'll do is go off camera and I'll do all the rest. And then we're ready to deburr these and turn it over to establish the center on the other side. So as you saw, I got the job done. This actually worked very well. But as you can see, it's got seriously beaten up. And I think I just didn't turn this down enough to a small enough diameter. I think this is just coming up right behind the insert and rubbing, so that's a bit unfortunate. But I got the job done, and the insert is actually nicely positioned. I've got that properly attached and supported. So overall, you know, the tool worked fine, did the job. So I'm pretty happy with it. What I'm going to do is put this back in the lathe and I'll skim this down, get rid of this rough stuff, and then that will be a usable tool. I'm not going to bother blackening it and stuff like that. I don't think that's really necessary. But anyway, shop made tools.